ESPN and all sports stations present their programs to their audience via satellite and cable television systems. In the U.S., either the State Utility Commission or the state government regulate the activity of cablecasters. Recently, there has been some federal legislation to regulate cablecasters as well. Local regulators in many communities have required cable companies to allocate certain channels for educational broadcasts and public access. Educators and community organizations may use these channels for educational programs, community forums, debates, or other varieties of programming that are in the public interest. Many cable companies provide small format video systems or small production studios to educators and community organizations to produce these programs. Programs produced in schools, colleges, and universities can also be distributed through local cable systems. Cable television systems can be designed and constructed to provide two-way communication between the user and the head end. This feature of cable television can be very useful in educational programming to provide direct communication between the instructor and students. However, the two-way capabilities of cable television have not been used nearly as much as this technology can offer. Recently, there are new developments among cablecasters to provide interactive television services. There have been a few test sites for interactive television, such as Cerritos, California, Denver, Colorado, and Orlando, Florida. However, wide implementation of interactive television will perhaps take place in the next 5 years. Cable systems are limited to municipalities and surrounding suburbs. For continental and intercontinental broadcasting, such as recent Soccer World Cup, communication satellites are used. Communication satellites were developed to provide wider geographic coverage as well as more channel capacity to broadcasters. These satellites are placed at 22,300 miles above the equator, which makes them rotate at a speed synchronous to Earth's rotation. Therefore, they appear to be stationary in relation to Earth. Communication satellites operate on super high frequency, or SHF, from 3 to 30 gigahertz. This provides more channel capacity to broadcasters. From 22,300 miles above the Earth, they also cover a wide geographical area and have a vast footprint. One of the most exciting events in telecommunications today is the use of ordinary telephone lines for image and text transmission in addition to voice. Through digital technology and compression of digital data, ordinary phone lines can be used for transmission of different modes of information representation. Two of the most interesting systems made possible by digital compression technology are compressed video and desktop video. Both of these technologies use digital signals to transmit voice, video, and text through phone lines, microwave satellites, and fiber optic lines. Now, let's take a look and see what is compressed video. Ordinary television broadcasts are in analog form. Among the characteristics of analog signals is that they vary continuously to represent voice or image. Digital signals, on the other hand, vary discretely in binary codes, or zeros or ones. Through digitizing and sampling, analog signals can be converted into digital signals and compressed so that more information can be transmitted through a channel. In NTSC television, images are transmitted at 30 frames per second. In compressed video, numbers of frames per second can be reduced. For example, some compressed video systems work at 15 frames per second. Image quality is reduced as compared to full motion video, but for many training and education applications, a system operating at 15 frames per second is acceptable. In parallel to compression technology, telecommunications engineers in search of more channel capacity have developed a new technology that uses tiny strings of glass to transmit video, voice, and data. These strings, known as optical fibers, carry light waves or monochromatic laser light beams with extreme high frequency, EHF, from 30 to 300 gigahertz, offering almost unlimited channel capacity. So far, fiber optic cables have been used for very long distances, such as between two cities. Because these glass fibers are no thicker than 100 microns, it is very difficult to splice them with precision, making them more useful in the construction of long-distance trunk lines than for short-distance networks. However, fiber optic networks are developing in urban areas rapidly. For example, Teleport Communication Group is establishing a fiber optic network here in the city of San Diego. Also, Pacific Bell, the regional telephone company which serves the state of California, also has committed to the development of a statewide fiber optic network. Digital technology, in conjunction with fiber optics, will provide even more interesting, useful, and exciting capabilities to broadcasters and educators. For example, new telecommunication standards, such as ATM or asynchronous transfer mode and cell relay, will provide broadcasters, educators, and trainers with two-way voice, video, and text communications, multi-point teleconferencing, and video on demand, to mention a few of the new services that are emerging now. What is certain is that the future will bring more and more exciting possibilities to professionals. Your capacities will be only limited by your imagination. In this segment of the program, I will introduce you to video production equipment. We will describe and analyze components of a simple video system. Since most educators and trainers will find this combination more suitable to their needs, we are going to discuss video editing or post-production system to show how users of a simple video system can produce relatively sophisticated instructional and training programs by editing their tapes, studio video production system for those who wish to explore a more involved form of video production, components of a compressed video system, as this technology is gaining more and more popularity throughout the world, and finally, components of a desktop video system, since this system is emerging as very exciting and personal means of video conferencing. In its most simple configuration, a video system consists of the following components: a lighting kit, a camera, a recorder, or a combination of a camera and recorder in form of a camcorder, a video monitor, a tripod and dolly, a microphone, and a pair of earphones. The most essential ingredient in television production is lighting. Without light, you cannot generate a video image. There are several portable lighting kits for small format production in the market. They range in price from $600 to $1,200, depending on accessories including umbrellas and barn doors. The function of a video camera is to change the light captured by its lens to an electric signal. The camera lens focuses the light and dark parts of an image on a photosensitive plate or an imaging device, a picture tube. The photosensitive plate emits electrons in proportion to the amount of light hitting its surface. An electron gun scans the surface of the plate and shoots off the remaining electrons from the plate's surface. The electrons are collected, turned into a signal, and sent to the monitor and the recorder. In the monitor, the same process is repeated in reverse. The electron gun scans the surface of the picture tube. The picture tube's surface is treated with phosphorus. When it receives electrons, it glows in proportion to the amount of electrons received, and a picture is formed on the screen. In the recorder, the electric signal from the camera is received at 2 video heads. Some VCRs are equipped with 4 video heads for longer playtime and special effects, which create a magnetic field. This magnetic field rearranges the tiny particles of iron oxide on the surface of the tape, thus recording the image on its surface. When the tape is played back, the video heads read the tape and emit a signal which travels to the monitor for viewing. The camera is placed on a tripod to make it stable during shooting. Often the tripod is placed on a dolly, a 3-wheeled base which facilitates camera maneuverability. The function of the microphone is to change sound waves into an electric signal. There is a plate or a similar component inside most microphones that vibrates, and it is hit by sound when it is hit by sound waves. The plate's vibration changes the magnetic field of an electric circuit surrounding it. The signal is passed through the microphone cable to the video recorder and is recorded on the audio track of the videotape and/or is sent to the speaker of the monitor. The audio and video process here was oversimplified here to provide a basic understanding of how they work. Video cameras can be classified by the size and type of their imaging device, the quality of their image, and their price. Another useful way to categorize them is by their application, which subsumes the other classifications. Broadcast quality cameras produce a high quality color video image like that you see on your screen. They have 3 pickup tubes for 3 primary colors of red, blue, and green, and range from $7,000 to $100,000 in price. These cameras are used for a variety of production purposes in the broadcast industry. Portable models are used for news gathering and documentary production. More expensive and larger cameras are used for studio production and the telecast of dramas, games, variety shows, news, sports, and educational programs. Industrial quality cameras produce a good quality color video image that may not be acceptable for broadcast purposes, but it is adequate for the majority of instructional, training, and corporate communication video productions. The cameras may have 3 tubes, in which case their price range from $3,000 to $8,000, or they may have a single tube with a price range of $1,200 to $3,000. Home quality cameras very often have only a single tube and cost under $1,000. Their color image is adequate for making home movies, but does not have the resolution required for the production of good quality instructional and training programs. Until a few years ago, video camera technology remained the same. Cameras used 1 pickup tube as their imaging device, or 3 pickup tubes as their imaging device. New video cameras, however, use a component called Charged Coupled Device, or CCD, for imaging. CCD technology has made the manufacture of smaller, lighter, and less expensive cameras possible. Hi-8 camcorders are an example of such high quality and small and relatively low-cost systems. Not only they combine a camera and a recorder in one unit, but they reproduce a high-quality image on a tape that is only 8 mm wide. The cost of these camcorders range from $1,200 to $3,000. Video recorders are often classified according to the width of the tape they take and the technique they use for recording and playback. Hence, half-inch VHS or video home system, 1-inch C format, Betamax, etc. Programs recorded in each format can be played back only on the same format. Therefore, half-inch VHS is not compatible with Betamax or 1-inch C format. 1-inch C format recorders are very expensive, $10,000 to $50,000 in price, and are primarily used by broadcasters who have to adhere to technical standards set for them by the Federal Communications Commission, or FCC. This format is useful to educators and trainers only if they wish to produce a program for broadcast or for transfer to video disc. 3/4-inch U has emerged as the most widely used video cassette recording format in business and education. Many public schools and institutions of higher education use this format for production and distribution of their programs. The price of recording equipment in this format ranges between $3,000 to $5,000 and is considerably higher than the VHS and Beta formats. The price of tape for this format is about $50 for an hour of recording. These recorders use only one speed. Used with a broadcast quality camera, they produce an acceptable image for broadcast purposes. They also come in light models for field production and remote broadcasts. VHS and Betamax recorders are less expensive, $300 to $3,000 in price, and lighter than 3/4-inch U format. But they cannot reproduce an image as sharp and as stable as the 3/4-inch U recorders. Nevertheless, they have found many users in corporate communication, schools, and universities. At the outset, Betamax was manufactured only by Sony, and its popularity did not increase as much as the VHS format. All other manufacturers made VHS tape recorders, which have rapidly gained the number 2 position in popularity after 3/4-inch U among video users. Beta and VHS cassette tapes are also much less expensive than 3/4-inch U format. Cassettes for VHS are only $6 in price, and they can be recorded in 3 speeds, providing longer recording and playback time. Standard play or SP speed, however, is recommended for professional use. This speed on VHS tape will provide 2 hours of recording time, 1 hour for Beta. Next, we will cover a number of other system components. Video monitors are most often classified by the size of their screen, such as 10, 13, or 20-inch. Generally, the bigger the screen, the higher the price. They range in price from several $100s to more than $1,000. Video monitors can reproduce the image they receive either directly from a camera or from a videotape recorder. Some monitors do not have a speaker, so they cannot reproduce sound. Monitors are used in small format productions for previewing a take as it is being recorded or after it has been recorded. Video monitors do not have a tuner and therefore are incapable of receiving a radio frequency signal. In other words, you cannot watch your favorite television program on them. Receiver monitors, however, have a tuner and enable you to use them for viewing broadcast television programs, viewing images and audio from a videotape recorder, or viewing live images and sounds from a camera or a microphone. Now, microphones come in a variety of shapes and forms and range in price from a few dollars to a few $100s. They are classified by the way they produce their signal, such as dynamic or condenser or crystal, or by the way they pick up sounds from the environment, such as uni or omnidirectional. Dynamic microphones have a very good frequency response and are used by many producers for voice and music. And tripods are used to support the camera during shooting. Very often, they are put on a three-wheeled base called a dolly, so the camera person can maneuver the tripod easily. The production equipment outlined and briefly described here will allow educators and trainers to record video segments for teaching, researching, or documenting subject matters and events. This production equipment, however, will not allow you to edit your program, rearrange the recorded sequences and titles, credits, and other graphics, or add narration or voiceover or music after the shooting is completed. Editing equipment combined with a video switcher and a microcomputer, an audio mixer, an audio playback unit such as a compact disc player is required to edit and produce complex video productions. Now, video editing equipment can be as simple as a playback unit, a source deck, a recorder, and an edit control unit, and 2 video monitors. While editing, you select a segment you have previously recorded on your videotape, the source tape, and literally duplicate that segment onto a blank tape, which will become your edited master. The edit control unit allows you to select precise points on your source tape and the edit master tape and transfer audio and video segments from the source tape to the edit master tape without a glitch between 2 shots. Simple editing systems for a 3/4-inch U-matic format cost between $10,000 to $15,000. The cost of editing equipment is lower for VHS or beta equipment. In these formats, an editing system can be purchased from $6,000 to $10,000. A simple editing system can be gradually augmented with additional components to provide more flexibility to the post-production process. For example, with the addition of a video switcher, additional video sources such as microcomputer or a video camera can also be fed into the editor deck. This enables the editor to use graphics generated in a microcomputer for titles, credits, and other purposes. Most microcomputers, however, do not produce a signal compatible with the standard video signal. Therefore, their output should be processed through an adaptive card, often called a NTSC, or National Television Standard Committee card. These cards are available for most microcomputers, and they cost between $1,000 to $3,000. Through a switcher, a video camera can also feed additional video segments, such as the image of a conventional graphic, or the image of a 3-dimensional model, or even a live announcer, to the editor deck. With the use of a switcher, the editor can produce a fairly complex and sophisticated video program. To further develop the post-production facility, a time-based corrector, or a TBC, can be added to the system. The function of a TBC is to synchronize the various video sources fed into the switcher. TBCs can stabilize the video output of a switcher and solve many post-production problems. But they are expensive, and only facilities with a healthy budget can afford them. The price of a TVC ranged from $8,000 to $20,000. To add music or voiceover narration onto an edited master requires an audio mixer, a microphone, and at least one audio playback unit such as a compact disc player. We need to add these components to the post-production facility. Another way of adding sound to an edited master tape is to take the tape to an audio studio that is equipped with a video recorder and add the desired audio segments. A new and exciting development in video production is the advent of digital editing equipment, also known as non-linear editing system or tapeless editing system. They allow you to digitize your video segments and save them on a computer disk as files. Software specially produced for these systems then allow you to choose among different file segments or different files and edit them together. Transitions from one scene to another scene are also software driven and can be handled in a variety of ways such as wipes, dissolves, mosaics, etc. with little effort. Graphics and special effects are also built in, so titles, credits, and captions can be produced and incorporated on the same system. Once you are done with the editing process, you can print your edited version to a tape for distribution and viewing purposes. Now, studio video equipment is expensive and usually requires a professional crew who have had extensive training and experience in production of video programs. A video studio, however, is a very flexible environment for video production and allows the producer and the director to produce a professional program. Most video studios consist of a soundstage or studio floor and a control room. The soundstage is equipped with at least 2, usually 3 broadcast quality television cameras, a light grid and lighting instruments, boom stands, and other types of stands for microphones. The control room is equipped with a video switcher, an audio control board, a light control board, several monitors for each video source, such as the cameras, camera control units, electronic measuring and monitoring instruments, such as vector scopes and waveform monitors, audio recorders, and playback units, such as audio cassette recorders, turntables, etc., a character generator or a computer for graphics, and many other types of electronic equipment to enhance and control the audio and video signals. In a studio production, each piece of equipment is run by a professional crew member. The director issues commands from the control room via an internal communication system or an intercom to the crew on the studio floor or in the control room. These commands can only be heard by the crew via their headsets and do not interfere with the flow of the program being taped or telecast. The commands are formal and specific and allow the camera personnel, audio personnel, and the rest of the crew to follow the show as it progresses on the studio floor. Audio and video signals in a studio production are often recorded on a 1-inch tape and edited after the production is complete. A compressed video system uses one or several video cameras, microphones, speakers, and monitors at each site to generate images and audio from the same site and present the audio and video generated in other sites. Video and audio generated at each site then goes through a unit called a codec or a coder-decoder. A codec digitizes the audio and the video signal strips 50% of the video image from 30 frames per second to 15 frames per second, and uses a proprietary algorithm to compress the video and audio and send the digital compressed signal through digital phone lines to the receiving site. At the receiving site, the reverse of this process occurs. Compressed video systems for each site cost from $20,000 to $50,000. At this time, most vendors